Alright, here's part 2 of the video where we're going to hook up the voltage supply. So in the last video, I just showed you a quick example of how the resistor part of the circuit was built on a breadboard, and now we're going to look at how we get the power supply there, or the voltage source. And the way we do that is using the OpenScope. So let me switch over to the OpenScope's menu. So if you plug in your OpenScope to the USB and get it up and running, two of the things that you'll see on the right-hand side of the menu here says DC power supply, and these are generally settable between plus 4 volts and minus 4 volts. So how about I pick 4 volts for the maximum? There it is, and notice that it, just because of the way the variable source works, it can't perfectly hit. It can't perfectly hit a number, but it'll go to the closest number that it can do based on what you pick. So for my own measurements, the set value is actually really close to the actual value. So now if I go over to the camera, now we need to get the OpenScope hooked up to this, and so if I look at all of my different leads on the OpenScope, well, actually let me switch back to the program, and if I go to the pins, the two that I'm looking for are DC1 and DC2, so it's solid red and solid white. Those correspond to these. So in particular, I'm going to look for solid red, which is channel 1. And let me go over to the camera. If I bring my OpenScope in here, what you'll see is it's one of the top wires here, fourth from the end, and if you look at the label on it, it says V1, so that's the one I want. And for hooking these up to the breadboard, what I would definitely encourage you to do is to look at your bundle of long jumper wires, and these things peel apart, and so we're going to generally try to pick colors that match the OpenScope wires, so that just makes it easier to kind of follow what's going on. So I'm going to take my V1. Alright, so you see the V1, I'm going to take my jumper pin, connect it in. So this basically acts like an extension. One nice thing about this is it means you don't have to have your wire, your OpenScope super close to your circuit board. So it just lets you kind of adjust things in a more convenient way. So now this resistor here is the one that's at high voltage. So yeah, let me just switch back to LT Spice real quick to show that. Right, so it's this R1 that's at high voltage. So I need to plug in to anywhere along row 5 here. I could pick any of these holes, so it doesn't matter which one, so I'm going to pick that one. And the other thing we need is a reference. We need a ground, and so there's a lot of different choices for ground pin. And if we go back over here, we can pick any of these. So how about I'll pick that black one, which is right next to DC1. So let me go back over to the video. Let me move that wire out of the way. Okay. So then if I look at my OpenScope cables, I'll see right next to my red one, there's a black one. Let me pull that out. Notice it's got that symbol, that little arrow kind of pointing down. Just stands for ground. It's a pretty universal symbol. It's the same symbol LT Spice uses for ground. I'm going to pick a black wire. Black is commonly ground. And let's plug in the black. And so where do I apply that? So I actually can apply that anywhere along this strip that's listed as negative. So any of these pins along the whole side would be sufficient. So now what I should have is a 4-volt difference between one side of the resistor network, which is plugged into ground, and then the other side of the resistor network, which is plugged into the, connected to the kind of the high voltage on the DC output of the OpenScope. All right, so let's actually flip on the source, and I'm going to go to volts, not millivolts, because I think I set this to a 4-volt scale. And if you want to just do a simple measurement, you can do that by plugging. We'll grab the rightmost lead, which would represent positive volt. The positive, then we'll put black on ground. So black will always be kind of our reference. So we'll typically connect that to ground. And indeed, what do we get? 4.01, which is very, very consistent with the actual set voltage in the OpenScope. So if I jump back over to the OpenScope, if I was to drop this down, like let's just pick a random number, 1.86 volts. All right, so the closest it can do is 1.856. And what do we get on the voltmeter? 1.855. So that's how the variable voltage source works. So hopefully this just gives you a little bit of sense also of just how to get the OpenScope plugged into the circuit board, which is one of the other important things you're going to need to do a lot. So that's it.